makes me feel a little nervous. You know, with this mic, probably I'm more nervous than what I've been otherwise. Today we'll be talking of sustainable water management for a resilient, water-conscious world. And I introduce myself as Deeksha Katyal, and I just don't write only my name. I make sure, since I'm just representing my team here, the team of lovely students that I have, whose photographs you're going to get to see. I belong to University School of Environment Management, GGSIPU, which is there located in Delhi. And the work that I'm going to present is basically, we have collaborators as DTU and INMAS, if you might have heard of, which it comes under DRDO. So, without further ado, I started working on water way back in 1999. I don't know, many of you might not have been born by that time. But initially I felt that there was the science itself of water, was difficult. In the sense, I was one who wanted to simplify science as much as possible, because I've always had this opinion that children run away from science thinking that there are such difficult concepts to understand. How is it that I simplify science? And in that endeavor, I started working on water. Why is water crucial? You'd come to know in these few slides. You can see these red areas that we're talking of, they are under high risk, which includes, of course, our country. This is the data that I'm presenting of 2023, and UN SDG goals, though, says that we should have clean water for everyone by 2030. Only 70% have access to safe water. Now, we are not talking of 10, 20, 30 people. We are talking of 2.2 billion people who would not be having access to water. Causes, of course, climate change, poor infrastructure, urbanization, and conflict that are happening within the countries. How can we prevent it? Let's see it in a little detail. The most affected regions amongst the ones that I've shown you, Middle East and North Africa, are facing 70% of this region is having scarcity of water, which majorly is because of water being the dearth of water and conflict. South Asia, wherein we come, has 60%. The major problem areas are contamination and overpopulation, and Sub-Saharan Africa, 30% of the whole area faces droughts and has poverty. So, on an average, 83% of the MENA population, which is the Middle East and North Africa, faces extreme water stress, which is due to, especially in countries like Bahrain, Kuwait, Qatar, UAE, Saudi Arabia. The challenges that they get to see is arid climate, over-extraction, high dependency on desalination. In South Asia, we have over 100 million people affected with groundwater depletion happening. And we've already experienced day zero in Chennai in 2019. I don't know how many of you are aware of what day zero is. Day zero is the day when the city supply stops providing any water. So we have already experienced it in Chennai in 2019, and Cape Town also narrowly avoided day zero in 2018. That means from that day on, when you have day zero, there will be no water available, at least for that particular city. The problem here is majorly that in such cases, rural population is the more majorly affected. Now, talking of India's projected water stress, if you see, these areas, if you would see, they all are covered. They all are being covered either in high or extremely high stress regions. Which means by 2030, there might be a situation where none of us are able to get free-flowing water. All of us are restricted, and it's a very, very dangerous situation. The photographs that you see is from Tanzania, wherein the lady is lifting up water from. I get overwhelmed seeing this picture. Because when we talk of human rights, water is a basic need. But many of us across the world are suffering, and this is not only from specific areas of Africa. In our own country also, there are areas where a huge water problem is existing. So all these issues, made me feel that water should be an area wherein I should devote my academic life to, and I sort of started categorizing how it should be that I classify water. So first of all, I thought of depiction and assessment, wherein through water quality and index mapping, I wanted to zone out the areas where the exact problem was. Second part was, could I do anything about better distribution of water, because agriculture was the one which was taking up majority of water. So was there any which way through which I could sort of help the better distribution? And third was removal. I could specifically work on, the idea was to work majorly on radionuclides and heavy metals. So I will just show you what exactly we have done. We've used RO membranes and titanium nanotubes in next 1-2 slides. And I'm so sorry, first of all, I should have apologized for making you people sit on a Sunday to listen to a lecture, and that was scientific one, but can't help it. So coming back to the first area, depiction and assessment. As you can see in here, these maps. So basically, mapping is done over depending upon the physico-chemical characteristics of water. That means you do the physical as well as chemical analysis of water, and thereafter you put it in a database which is done through GIS. GIS is Geographical Information Systems, and it is a way of generating the data. So basically you have query points where you can put in the data, and the whole, this is of Delhi, so the whole area is digitized. Any kind of query you can put in, any kind of data you can put in, and you can derive a relation between it. Now there was two kind of assessment that I was making. One was index mapping, wherein I was trying to understand what is the current status of water. And then there was vulnerability mapping, through which I was trying to understand what would be the future of water. So 10 years, 15 years down the line, how would the water behave in various seasons is what I'm trying to depict here. See, this one is in pre-monsoon, post-monsoon, and winter season. All of this is vulnerability mapping, which is predictive in nature. And index mapping and vulnerability mapping can be put over each other to get in these overlays. As you can see, you can make out how they would be varying through years. How fertilizer is affecting the water quality, that we did in Pravra region, Maharashtra. So basically everywhere we could identify where the problem was, how the problem is changing. Now, what do I just do by identifying? The idea was to find out if it is causing health risk also. So we did some experiments in Gurugram as well as Panipat in the vicinity of the industrial zones to see if they were doing some discharge. And as you can see, we found that skeletal diseases were happening. You could see dental fluorosis and skeletal, especially in Gurugram region, which were coming out because of the heavy metal pollution in this contamination. Alright. Besides this, as I told you, the other idea was how is it that I conserve water, for which I sort of designed these titrazine hydrogel we designed, which swells up to around 2000. Its original. Can you see this? Okay. It swells up to around 2000 its original size. It can very well distribute urea or the nitrogenous fertilizers well within the soil, and since it is derived from chitosan, which is completely organic in nature, it doesn't leave any residue in the soil. This one is to show that how from 2 days the retention of water is increasing up to 4 to 5 days, both in different kind of soils as well as the urea dissipation. And the third objective was to radionuclides and heavy metals removal, which I did through various RO membranes. This was interesting in the sense that lower radioactivity we saw. In case of any accident, can your RO itself help you remove the radionuclides? And we found that yes, it does help a lot in the sense of 92 to 97% can be removed. However, for higher concentration, we've designed this much chip which can be installed directly into your RO. So in case of any event, radiological event, I mean an accident that happens, we are already ready, the country is already ready with its device. I think I would just this is my team. We are a bunch of girls. For past 7-8 years we have been working together. Somehow it has been that and these are beautiful pictures wherein we celebrate each achievement that we make. Before I just proceed on to the other slide, one thing that I purposely came here was for, initially during my research days, I was told over not to do research in this field because not much of data was available, softwares weren't available. However, I kept on doing that research. My request to you all is, you must be at the juncture of your life where people would tell you, probably this is not the right thing to do. I kept working on mapping, and here's where it took me. I got an opportunity, I was felicitated by the Prime Minister. I was called over for my work on Ganga, wherein, thank you. And my name was also taken in Man Ki Baat. So the idea here to show you this is, don't let anybody tell you what to do, how to work. Keep on working, and I'm sure results will come over. Your time shall come over. Thank you, Ashutosh sir, Neeti ma'am. They don't know actually somehow how many lives they've touched and how many lives have they transformed, including mine. And you can connect me just in case you want to at any of these emails. Thank you.